Good morning, geometry. Today we are looking at 8-2, which we're moving into our trigonometry unit. Trig is not that hard. It's so very easy. Once you get the hang of it, you'll be able to solve these right triangles very, very quick. This is just something I learned a while back to help me remember. Some old hippie caught a hippie tripping on acorns. I know it doesn't make sense, but it helps me to remember that the S, O, H, C, A, and the H, and T, O, and A all help me. It's just an acronym to help you remember your trig functions. The S stands for the first trig function, which is sine. We don't really put the E on the end, but that's how you actually pronounce it, sine. We normally just use I and N. The second trig function is cosine. And you'll normally only see cos, C-O-S. And the third trig function is tan, which is short for tangent. The O and the H for some old hippie comes from, with sine, it is equivalent to the opposite side of the right triangle, or whatever angle you're trying to reach, divided by the hypotenuse. I just had a brain fart. I can't think how to spell hypotenuse. Okay, yeah. And cosine is equal to A is the adjacent angle divided by H, which is the hypotenuse. And tangent is equal to O, which is the opposite, divided by A, which is the adjacent. So some old hippie caught a hippie tripping on acorns is S for sine equals opposite over hypotenuse. Cosine is adjacent over hypotenuse. Tan is opposite over adjacent. And right here on example 1, we're going to look at, everybody get that down, pause if you need to, copy it down. We're going to look at some examples and you'll be able to see what I'm talking about on an actual right triangle. Example 1 says, write each trig ratio as a fraction and as a decimal rounded to the nearest hundred. So when we look at the figure, we have a triangle. And sorry, I'm missing the, okay. This is R. This is T, and this is S. Hold on one second. Okay. This is worth 13. This is 5, and this is 12. And if you use Pythagorean theorem, you'll see that it's a 5, 12, 13 triangle. And that 5 squared plus 12 squared equals 13 squared. So this is how you use trig. So it says find the sine of R. We know this sine is equivalent to the opposite over the hypotenuse, right? And since we want to find the sine of R, we're going to come to R. This is the angle right here. And the opposite of R right across from it is 12 units. So here the sine of R is going to equal 12 over, and then H stands for the hypotenuse. And of course we know the hypotenuse is the diagonal right across from the right triangle, and the hypotenuse is 13. So the sine of R is 12 over 13. Cosine of R. So we're at R now, and I'll get a different color. And cosine, if you remember, or if you look above, is adjacent over hypotenuse. And so the cosine of R, we'll come to R. Remember, adjacent is right next to it. The adjacent side would be 5. Some of you might ask, why is 13 not adjacent? Because it's right there, because 13 is the hypotenuse. That is the hypotenuse, so it's the other leg. So the adjacent leg is 5, and then the hypotenuse, of course, is 13. If you had used 13 as the adjacent, you had 13 over 13, it would have been totally incorrect, because 13 is the hypotenuse. And the tan is opposite over adjacent. And so we're finding the tan of S in this problem. And my pen's acting up, of course. So tan, we're doing opposite. So here's S. And so opposite of that will be 5. And then adjacent right next to it would be 12. And so I think my pen's acting right now. Yep. Okay, so tan of S is 5/12. Got it? And then it also said to round to the nearest hundred. So of course you just put it in your calculators, and 12 divided by 13, this is going to be equivalent to 0.92. 5 divided by 13, this one is equivalent to 0.38. And 5 divided by 12, this one is equivalent to 0.42. Got it? And so that's examples of sine, cosine, and tan. You need to pause it so that you can take a moment to kind of digest what opposites and hypotenuse is, and pause. If not, we're moving on to example 2. All right, example 2 says to use special right triangles. I've skipped a unit. We should be looking at I'm gonna pause it.